Hello there, this is Miss Nakayama, and today's lesson is 4.4 Trigonometric Functions of Any Angle. So in the previous lesson, we evaluated all angles that were on the unit circle, and this lesson we're going to concentrate on those that are not on the unit circle. So that's going to be the first thing that we're going to cover, any angle, not just those that we find on the unit circle. Then we're going to be able to determine the sign of any trigonometric function, and then we're going to use reference angles, find them, and use them to evaluate trig functions. So first and foremost, definition of trigonometric functions at any angle. So as I said before, we were working on the unit circle, and the equation of our circle was x squared plus y squared equals 1. Well, now we're talking about any angle, and so instead of being the unit circle where we have a radius of 1, we're going to have a circle centered at the origin, but the radius can be anything. Okay? So what's important about that is we're going to have theta any angle in standard position. P is some point on that circle. And that means if I take this equation here and solve it for r, I'm going to get r is equal to the square root of x squared plus y squared. So that's that distance. Here's a picture down here showing you just like the Pythagorean theorem. Okay? And all of the trig functions are going to be defined similar to what we had in the previous lesson, but instead of being on the unit circle where this was 1, we now have r. But otherwise, we're going to do the same thing, and y'all, it's just SOHCAHTOA. The sine of this angle right here, theta, is opposite, which is y over r. So before we had just y, and now we have y over r. Sine is y over r, cosine is x over r, tangent is y over x, where x can't be 0, and then you flip each of those. So the cotangent is x over y, where y can't be 0, secant is r over x, and cosecant is r over y. Again, I don't put as much stock in those reciprocals. What I really care more is that you know that these two are reciprocals of each other. So if you get this one wrong, I want you to get this one wrong because all you did was flip that answer. All right, so look at what you're going to have to be able to do in one of the examples here. Come up a little bit. All right, so I have let P be a point on the terminal side of theta. Find each of the 6 trigonometric functions of theta. So the difference again in these problems and what you did yesterday is one or both of these numbers is larger than 1. And if it's larger than 1, it can't be on the unit circle. However, it still represents x and y. And so we're still going to use our Pythagorean theorem, or the equation I just gave you, which is x squared plus y squared equals r squared. And I'm going to plug in for x and y. And I want to stop a moment here and point out that I put 3 instead of -3 because I think y'all have heard me say this enough this year. Whenever you square a number, it's always positive. So that negative, when people put it in the problem, y'all, they miss it because they don't put it in their calculator correctly or they don't evaluate it correctly. So I'm just telling you, if you're squaring the number, the negative does not matter. So r squared equals 10. R equals plus or minus the square root of 10. But in this problem, r is the square root of 10 in all of these problems because r will always be a positive value. X and y can be positive or negative, but r will always be positive. So sine is y over r, and y is -3, and r is the square root of 10. So I have -3 over the square root of 10 that I have to rationalize, and that becomes -3 square root of 10 over 10. Now, it is easiest to go ahead and go do the cosecant because the cosecant is r over y, and if I just flip this before I rationalized it, then I have my answer of square root of 10 over -3. So it's much easier to flip it here than it is here. So that's why it's kind of important and helps you to actually write this on your paper. Okay, cosine is x over r. X is 1 over the square root of 10. When I rationalize it, it's going to become the square root of 10 over 10. And then the secant is going to be r over x, so I'm going to flip that, and it's going to become the square root of 10. Tangent is y over x. and y over x in this case is just -3. Cotangent is its reciprocal, x over y, so that's going to be -1/3. And that is all that you do every single time you have to do these problems. Pay attention to whether or not either of these numbers is bigger than 1. This is what you'll have to do. All right, so the signs of trigonometric functions. Okay, this is showing you, this little picture here is showing you in quadrant 1, all functions are positive. In quadrant 2, the sine and its reciprocal. In quadrant 3, the tangent and its reciprocal. And in quadrant 4, the cosine and its reciprocal. Some people like to remember the mnemonic device that I have underlined the first letter of each of these. And the mnemonic device, people remember, it says all students take calculus, which we of course know isn't true, but it is a device to help you remember that all functions are positive here, sine and its reciprocal here, tangent and its reciprocal here, and cosine and its reciprocal there. So, type of example that you will have to do. Example 2, finding the quadrant in which the angle lies. So, if I know that the sine is less than 0 and the cosine is less than 0, name the quadrant in which the angle theta lies. So remember, sine is my y-coordinate and cosine is my x-coordinate. So if you think about your quadrants, okay, where is the sine negative? Well, the sine is negative here and here. And the cosine is negative or less than 0 here and here. So where is the overlap? It's clearly right there. So that means that quadrant 3 is where my angle lies. That is the type of thing. This is like a small part of a problem that you got to be able to do. So we're going to go do some of those. Again, if you want to check your work, look back at our little picture that we had, and you can see that the sine is negative and the cosine is negative in that third quadrant. Okay, evaluating trig functions. So here I have, this is the kind of thing you're going to have, and you got to know whether or not your answer is going to be positive or negative, and that was kind of what we were just doing. So given the tangent of theta is -1/3 and cosine of theta is less than 0, find the sine and the secant. Okay, so first of all, you need to remember that the tangent is y over x. Okay, and when you do that, you're going to come down here and say, okay, well, I'm going to remember that x squared plus y squared equals r squared, and I'm going to ignore that negative, and so I know that, again, I flipped it, doesn't matter, y'all, because you're adding and the order doesn't matter. 1 squared plus 3 squared equals r squared. R equals the square root of 10. We kind of just went through that on the last problem. But what you do have to know is, where does this negative go? Does it really apply to the y or to the x? So using this given information and this, I need to determine what quadrant it's in, or I'm not going to know whether the sine and the secant are positive or negative. So when I do this problem, again, I'm going to think of my little quadrant system here. So I have cosine is negative, and the cosine is negative here and here. I give away the answer. And the tangent is negative here and here. So this is where our answer is up here in the second quadrant. And in the second quadrant, x is negative and y is positive. So that means that the sine is the y-coordinate. That'll be positive. The secant is the reciprocal of the cosine, so it will be negative. So you can go ahead and answer that part of it, but we'll go ahead and finish. So the sine of your function is y over r. Actually, let's go with this. So back up here, when I said that we know it's in the second quadrant, when you look at this right here, that tells you that the y is positive and the x is negative. So you need to think about that negative sign goes with the 3 because the y is positive. So in y over r, I'm going to have 1 over the square root of 10, and we rationalized that before to give me the square root of 10 over 10. Secant is r over x, and r is square root of 10, and x is -3. So we have negative square root of 10 over 3. Okay? If you have any difficulty with that, you need to come see me, practice those problems. All right, but this is kind of an important part of it because every time you evaluate a trig function, y'all, half of the answer is the actual value of it, and the other half is whether you know it's positive or negative. So it's an important part of the problem. Okay, now we need to talk about something called reference angles. Okay, and the most important thing about a reference angle to me, y'all, if you can remember the definition, you won't get this problem wrong. So I'm going to emphasize it. A reference angle is a positive acute angle theta prime formed by the terminal side of the x-axis. So it is positive acute angle formed with the x-axis. So look at these pictures down here. Okay, here is your angle. They show you in each case theta prime. That is the acute angle made with the x-axis. This is the acute angle made with the x-axis. This is the acute angle made with the x-axis. So you can remember all this down here, but I think it's a little bit easier if you remember if the angle ends up in the second or third quadrant, you're going to use 180, and you're going to see when I go do this. And if it ends up in the fourth quadrant, you're going to use 360 to figure out what the reference angle is. And y'all, well, look at this. When you do these problems, I know that you might be able to punch them in your calculator, but you can't see that later on down the road, you need to understand the importance of these reference angles. So practice them now when they're easier for you so that you will understand them. Again, it is, what did we say it was? It was a positive acute angle made with the x-axis. And the picture that I draw to help remember it is if my angle ends in the second or the third quadrant, I'm going to find the difference with 180. And if it ends in the fourth quadrant, I'm going to find the difference with 360. So this first one is 210. And 210 is clearly just past 180, so it's down here. So I'm just going to subtract 180 from it and find out my reference angle is 30 degrees. Okay? And so actually what I also want to point out, if it's an acute angle, y'all, then you know that every answer has to be less than 90 degrees or less than pi over 2. So if your answer is not, then you've done something wrong. That goes all back to the definition. Okay. B, theta equals 7 pi over 4. Y'all, the beauty of the unit circle is if this angle is on the unit circle, meaning its denominator is either 3, 4, or 6, then the reference angle is just pi over the denominator. So in this case, it's just pi over 4. That's how easy it is. Okay? Negative 240. I would encourage you to make that, find the coterminal angle that's positive. So in this case, I'm going to add 360 to it. And when I add 360 to that, I get 120. And 120 ends up here before 180. But remember, up top here is 90. Okay, and you're never going to use 90 when you're finding a reference angle because the reference angle is made with the x-axis. So 90, you got to know that 90 is on the vertical. So I'm going to do 180 minus 160, and that gives, 180 minus 120, which gives me 60 degrees. Okay. D is 3.6. Where the heck is 3.6? So what you have to do is come up with a quadrant system, and I'm going to do it in terms of radians. Okay? So I have 0 on the right, but all the way over is pi. As a decimal, pi is 3.14. And all the way around is 2 pi, which as a decimal is 6.28. And you kind of have to know that number because if you don't, well, it didn't come. So over here is 6.28. Okay, half of pi is up top. That's pi over 2. That's 1.57. And if you add those two together, 1.57 and 3.414, you'll get 4.71. So those are my numbers in terms of radians, the decimal approximation, which is what 3.6 is. So surely you can tell me that that falls down here in the third quadrant. So what am I going to use to subtract? I'm going to use pi, which in this case, or 180, which but I have the decimal because they gave me a decimal. So I'm going to subtract 3.14, and I'm going to get an answer of 0.46. So pi over 2, as you can see from our diagram, is 1.57. Okay, E, theta equals 8 pi over 7. 8 pi over 7, that's not on my unit circle, okay? But where is pi over 7? Pi is over there on the left, which is the same thing as 7 pi over 7. So 8 pi over 7 is going to be just past it, which means I'm just going to subtract pi from it. When I subtract pi, as I said, pi is the same thing as 7 pi over 7. And when I subtract that, I get pi over 7. Okay, now look at this next group. It's a little different because all of these are bigger than 180, or excuse me, bigger than 360. Okay, so as I said, you want to bring the angle down to between 0 and 360, so you'll know what to do. So 665 minus 360 is 305. Okay, where's 305? What quadrant? Fourth quadrant, which means I'm going to use 360. And 360 minus 305 is 55 degrees. B says 15 pi over 4. Is that on the unit circle? Anything that ends in a 3, 4, or 6 is on the unit circle. So my reference angle is just pi over 4. Okay? C, theta equals negative 11 pi over 3. Again, on the unit circle, it's pi over 3. But a lot of mistakes people would make is they would try to put that negative in there with it, y'all. And remember the definition. It is a positive acute angle made with the x-axis. So it doesn't matter if this is positive or negative. The reference angle is always positive. Okay? 12 pi over 5. 5 is not on my unit circle. So I have to think about that quadrant system. All right, I got 0. I have pi. I have pi over 2 up top. So where is 12 pi? Well, 5 times 2 is 10. So all the way around is going to be 10 pi over 5. Halfway around is 5 pi over 5. So where is 12 pi over 5? Well, it's clearly more than a whole circle around, so I'm going to subtract 2 pi from it. And when I do, I'm going to get 2 pi over 5. And you need to know what is halfway to know whether or not that's the answer. So half of 5, and y'all, doesn't have to be simplified, but half of 5 is 2.5 pi over 5. So that means that 2 pi over 5 is my answer. Okay, so the last thing we have to talk about is using these reference angles to evaluate trig functions. And the gist of it is, y'all, okay, the reference angles, the value of a trig function is the same value that the reference angle has. The only thing that changes is the sign. You have to pay attention to the sign. So that's why they're saying there's always two parts when you're using this, when you're evaluating a trig function. So the first thing you're going to do is find the value of that trig function, and then you're going to find the sign of the trig function. So watch this. Just a few examples, and then we're done. So in this particular case, sine of 300, well, what is my reference angle? 300 is close to 360, so if I subtract 360, I'm going to get my reference angle is equal to 60. And when the reference angle is 60, y'all, the sine of 60 is the square root of 3 over 2. Now I have to decide whether it's positive or negative. What quadrant is 300 in? It's in quadrant 4, and if it's in quadrant 4, then my answer is going to be negative. So that's all it is. And you're, again, questioning, well, I can just put this in my calculator. This is the kind of problem that will be on your non-calculator portion of the test. And as I said, moving forward, you don't know what we're going to do later on down the road, which is why you need to know reference angles. Okay. Use reference angles to find the exact value of 5 pi over 4. Okay, reference angle is pi over 4. The tangent of pi over 4 is 1. Go back. The reference angle is 1. 5 pi over 4 is in what quadrant? It is in quadrant 3, and in quadrant 3, both signs are negative, So that means the tangent's positive. So my answer is positive. All right. I think, oh, two more. Okay. The secant of negative pi over 6. The reference angle, pi over 6 is on the unit circle. So my reference angle is pi over 6. The coordinates of pi over 6 are square root of 3 over 2 and 1/2. And the secant is 1 over the cosine. This is all to find the value. 1 over the cosine. This means I got to flip this guy right here. So when I flip that guy, I get 2 square roots of 3 over 3. What quadrant is negative pi over 6 in? It is in quadrant 4, where our signs are positive and then negative. So my answer is going to be positive. And that's what we've got. So you kind of got to know the value, and then you got to know where the angle ends up. All right, last problem. Use reference angles to find the exact value of the cosecant of negative pi. Well, if you remember, negative pi is on an axis, so it's called a quadrantal angle. Okay, it is over here where its coordinates are negative 1, 0. Okay, cosecant is 1 over the sine, so that means that is the y coordinate, and 1 over 0 is undefined. And that is all we have. So I hope you remember. Write it down if you can't remember. The reference angle is the positive acute angle made with the positive x-axis. No, made with the x-axis. Positive acute angle made with the x-axis. Thank you so much for watching, and y'all have a great day.